and I am thrilled to present the Agriculture Advisor Agent, an AI powered system that transforms how farmers in Kerala make crop planning decisions. This project is my capstone for the 5-day AI Agents intensive vibe coding course with Google, where I learned to build autonomous agents from foundational concepts all the way to production ready systems. Today, I will show you how a 4 agent AI system can solve real farmer problems by reducing decision time by 95% and improve profitability by 23%. So, let's dive in. Let me start by explaining the problem we are solving. Farmers in Kerala face a critical challenge every season. They things like what crops should I plant? Will weather patterns increase disease risk? How much profit can I actually make? How do I make data driven decisions? To answer these questions, they must consider multiple factors simultaneously. What soil type do they have? What's the current season? What are their budget constraints? What are the weather patterns? What are current market prices, etc. Traditionally, answering these questions take 4 or more hours of research, consulting multiple websites, talking to neighbors, and guessing based on past experience. The result, too often, farmers make poor decisions that lead to crop failure or significant loss profit. This is exactly the kind of problem where AI can make a real difference. So, here is our solution, a multi agent AI system with 4 specialized agents working in parallel. So, the first agent, which is the crop planner, it filters suitable crops based on the season, soil type, and budget constraints. Think of it as your knowledgeable friend who knows which crops are possible. And the second agent, which is the disease detective, it fetches real time weather data from APIs and analyzes disease risk for each crop. This agent protects your harvest. Third agent is the market advisor. It calculates profit potential for each crop and evaluates market demand. This agent looks out for your wallet. And finally, the fourth agent, which is the decision synthesizer, it takes all the insights from the other 3 agents and combines them using a weighted formula to produce a final recommendation. What makes this system powerful is that all 4 agents work in parallel, sharing information seamlessly. This is the autonomous agent architecture in action. Let me walk you through exactly how the system works. A farmer gives 4 inputs. First is their district in Kerala, the current season, their budget, their farm size in acres. These inputs flow through 4 agents and the agents analyze multiple dimensions simultaneously. They give crop yield potential, disease and weather risk, profit calculations, market demand trends, etc. And the system then produces a comprehensive output that includes the recommended crop with a score of 0 to 10, expected profit in rupees, a detailed risk assessment. All of this analysis happen in less than 5 seconds. Compare that to the traditional 4-hour manual research approach. This is the power of intelligent agent orchestration. Let me show you a real example from our system. Imagine a farmer in Thrissur district during the monsoon season. They have a budget of 50,000 rupees and 1 acre of land. They input these parameters into a system and here is what they get back. The system recommends coconut and why coconut? The system reasons through this. Coconut has an excellent yield potential at 9.2 out of 10, maximum profit opportunity at 1,25,000 rupees, and safe disease resistance at 8.9 out of 10. Disease risk is minimal at only 2.1 out of 10. Market demand for coconut is high, which means the farmer can easily sell their harvest at good prices. So the system doesn't just give a recommendation, it explains why that recommendation is the best choice. This transparency is crucial for farmer trust and adoption. I will show you the exact how I do it through an HTML file. Here it is. Here I have a prepared demo series for the Thrissur, and the AA recommendation is like this. So this is how we do it. So coming back to the presentation. So now let me briefly touch on the technology that makes this possible. We developed this system in Google Colab using Python. The architecture is a custom multi-agent orchestration system. For real-time data, we integrate with the Open Meteor Weather API to fetch current conditions for all 14 Kerala districts. The backend runs on Flask with Gunicon. We containerized everything with Docker for reproducibility. Finally, we deployed the entire system to Google Cloud Run, where it runs 24/7 in production, accessible to farmers via public API endpoint. This deployment demonstrates all the concepts from day 5 of our course: production grade development, cloud deployment, and observability. Let me show you the impact we have achieved through the rigorous testing. First, time reduction, which is 95%, and second, which is the accuracy, which is 87%, and the profit boost, which is 23%. And fourth is the concurrent capacity, which is 100 plus. We tested the system with over 100 concurrent requests. It handled them all without performance degradation, proof that this is scalable system. We tested across 50 plus scenarios covering all 14 districts in Kerala across different seasons and farm sizes. Most importantly, this is a practical system solving real farmer problems. So why this matters? Because it demonstrates that AI can solve real world problems for real people. Farmers can now make data driven decisions based on actual current conditions, not guesses. We use live weather APIs to bring real-time intelligence to decision making. The entire system is deployed and production ready on Google Run. And critically, we have demonstrated governance, scalability, and observability, the core concepts of the production grade agent development. This is building AI for good. So thank you for watching. If you would like to explore the system, you can find the complete code on my GitHub and test the live API at the URLs shown. Thank you, and I hope this demonstrates what possible when we combine intelligent agent design with real world problem solving.